Hello everyone, this is H1 Mathematics. We are currently in Chapter 6, Applications of Differentiation. So this video is actually a follow-up video to our previous lectures. And in this video, we're going to go through all the exercises behind each subtopic in each subchapter. Okay, so let's get right in, right? And let's go to exercise 1. So for exercise 1, our topic here is actually the topic on the equations of tangents and normals. Okay, so what are we going to do here is for this particular question, we are going to find the equation of the tangent to the curve y equals to this whole thing at a point 1, 3. Right, so starting from y, right, so if I were to write this out nicely in a friendlier form, so this is y equals to x power 4 plus 4x plus 4 whole thing to the power of half. Okay, and I think it will be important to recognize this form. So this form over here, it is the chain rule form, right, the power form. So if we were to perform dy dx over here, right, so this would be half. Okay, copy and paste first, power minus 1, and then we differentiate the content over here. So this will be 4x cubed plus 4, right? So altogether, if you were to write it out properly, right, I can do is I can take 2 and factorize this, or more like divide by that. So at the end of the day, I will get a 2x cubed plus 2 whole thing over. Now then I will settle this thing over here, negative and a half. Negative means denominator, the half means square root, right, of x power 4 plus 4x plus 4. Okay, so this is the first thing that we'll do. Okay, now, so let us plan a little bit on what to do next, all right? So in order to find the equation of tangent, right, equation of tangent, obviously what we need to do is we need y equals mx plus c, or more importantly, we need y minus y1 equals to m of x minus x1, right? So equation of tangent, right, we will need two different ingredients, right? And the two different ingredients are we need the point and we're going to need the gradient of the tangent. Okay, now gradient of tangent, right, comes from dy dx, and this is the step that we have already completed. Okay, now the point over here is 1 over 3, and this is already given over here, right? So what is for us to do is to link up dy dx to the gradient of tangent, but at this specific point over here, right? So over here, so at the point 1 and 3, right, the value of dy dx. Now pumping this into your GC, you should be getting. Okay, so this one that we are subbing in, right, is actually x equals to 1 because we are subbing in the value of x over here. Okay, so we are subbing in values of x. So over here, dy dx is equals to 4 over 3, right, using your calculator. Now for this, right, at the end, what do we need to do next? We have to write down equation of tangent. So presentation, so equation of tangent is y minus y1 equals to the gradient of x minus x1. Okay, x1 over here is 1. So where do we get this is y1? Okay, in case you don't know, this is y1, this over here is x1. Okay, the point over here, right? So putting the point into this equation of tangent. Okay, now then I think let us expand and let us simplify. So over here we have a 4 over 3x, right? And then after simplifying, we get 5 over 3. Okay? Now, a little bit of extension. If they were to ask us to express in the form of ax plus by equals to c, right? So this tells us that the x and y must be on the same side of the graph, right? So, and then we will need to make it linearized where a and b and c are integers. Okay, so what do we need? Okay, where a, b and c are integers, so we need to make them whole numbers. Okay, Okay, so currently they are not whole number because the denominator has a 3. So the extension that what we can do is we can just multiply everything by 3. So on the left times 3, 3y. On the right times 3, we'll get this. Right, then we will manage this to rearrange this to get 4x minus 3y equals to negative 5, like this. Okay, so it will be in this form over here. Okay, right, so this is just an extension that we have. Let us continue to to question number 2. So we have the gradient of the curve for this particular curve. Okay, right, at the point where x equals to 2 is 12. So this tells us that this 12, right, is the gradient of tangent. Okay, so what do we need to find is we are looking for the the equation of the tangent to the curve at the same point. Okay, all right, so let us do some things and do some planning over here. So what do we need? We need equation of tangent. Right, so equation of tangent, right, now here what do we need? We are going to need the point, correct? Right, and what's the point? X is equals to negative 2. Y, right, actually we don't know, right? And why we don't know the value of y? Because we still need to find the k, right? So we need to find the k. So this is a heuristic of working backwards. Okay, now let us figure out how do we find the k. What information is given to find the k, right? Now let's look at the other branch on top of the point. We also need gradient of the tangent, and the gradient of tangent, right, is actually equals to 12. Okay, so technically speaking, right, then how do we link k and 12 together over here? Okay, so what we can do is we can actually, where does this gradient of tangent come from? It actually come from dy dx, and the dy dx, right, will probably has some k inside the expression, right? And because of that, right, we can make use of dy dx and the fact that the tangent is equals to 12 to actually find the value of k over here. Okay, so technically now we see that this is a game plan already. So we'll start with differentiation over here, and we'll link k with this gradient of tangent. Okay, so first y equals to x power 5 plus kx squared. So when we differentiate dy dx, this will give us 5x power 4 plus 2kx power 1. Okay, so we've done differentiation. Next one, the gradient of tangent is 12, already done, but we can link this to k, right? So when x equals to 2, negative 2, so dy dx, the gradient of tangent, is equals to dy dx, and this is equals to 12. So this expression, 5x power 4 plus 2kx is equals to 12. Alright, then we also need to know that x equals to negative 2, right? We can put into here, we can sub in here. Okay, so when we put in negative 2, so we've got 80 over here, right, minus 4k equals to 12. Now solving for k, right, k would be equals to 17. Okay, so now that we've already done this, it's left for us to find the value of y when x equals to negative 2. Okay, so back to this, right, so this tells us that the value of y is going to be equals to 5 x power 5, x power 5, right, would be negative 2 power 5 plus 17 times negative 2 square. All right, so this over here will give us the value of 36. Okay, so last but not least, we can now find the equation of tangent at the same point. Now, so now we've gotten the point already, right? We've gotten this y already. So we'll make use of the point and the gradient to look for the tangent, right? So y minus y1 is equals to the gradient m x minus x1, like this. Okay, so expanding, so y will be equals to 12x plus 60, and this will be the equation of tangent for question 2. Okay, so once again, the whole strategy is you get this and then we will work backwards, right, to find what we want to find, and then pull everything up together in sequence, starting from the furthest one to the nearest thing to do. Okay, so this is a strategy for question 2. Okay, moving on to question 3, we have the graph of y equals to ax cubed plus bx passing through this point 2, 2, all right? And the gradient at this point is 17, right? So what we want to find is find the equation of the tangent to the graph at x equals to 1. So this one, okay, we need to realize that the information given is for x equals to 2, right? But then the equation of tangent over here, we are looking for at x equals to 1. So we are talking about different points, right? But however, right, we'll probably need to make use of this information to solve for A and B first. Okay, so now let's think about the heuristics of working backwards also, right? So we start with, as in we will end with equation of tangent, right? So what we will need is, we are going to need this, right? We are going to need two ingredients. Number one being the point, right? And the other one would be the gradient. Okay, so the gradient of tangent. Okay, so this equation of tangent, right? We are going to need the point, right? We're going to need the point x equals to 1. Y, we actually don't know, correct? Right? Basing on this information, we need x equals to 1, right? And then the gradient of tangent, we actually need our dy dx. Okay? dy dx, right? However, dy dx, right, it is impossible to find, right? Because we still need to find, and this y, right, is also still impossible to find for now, because we still need to find what are the values of a and what is the value of a and what is the value of b, right? So how are we going to do this is we're going to make use of these two ingredients over here, right? We're going to have the point 2, 2 over here, right? So this one being x equals to 2, y equals to 2 over here, right? To solve partially this. And at the same time also the gradient, right, x equals to 2. The gradient is actually dy dx equals to 17. Okay, the gradient dy dx equals to 17. So if we want to look at the sequence of what we are going to do, first of all, we will need to get these two things ready in order for us to solve a and b, right? After that, using the a and b, right, putting this into the dy dx and putting it to find the y, then we can form equation of tangent using the line of the equation of a straight line. Okay, so what we're going to do is first we're going to start with this lah. Okay, this part over here. So at, right, at the point 2, 2 over here, right? So y is equals to 2, a 2 cube plus b 2, right? So over here 2 equals to 8a plus 2b. Okay, so with this over here we have divide by 2, right? So 1 is equals to 4a plus b. So right here we have our equation 1. Okay, so this one done. So this information done. Okay, next information over here, we can make use of dy dx equals to 17. So probably we need to find dy dx first. So dy dx is going to be equals to 3ax squared plus b. Okay, so when x equals to 2, then dy dx equals to 17. So we have 3a sub in the 2 square plus b equals to 17. So multiply, we get 12a plus b equals to 17. Okay, so 3ax squared plus b, correct? So something like this. So this over here, we have our equation number 2. Okay. So over here we have a pair of simultaneous equation. So what we can do over here is you can solve it manually because, right, actually you can eliminate very easily lah, right? You can eliminate this really easily, right? However, if you were to use the GC and put in, right, A would be equals to 2, B would be equals to -7. Okay, so right here what do we have is y now becomes 2, right? A is 2, so 2x cubed minus 7x, right? So from here I'm going to sub in my 2 and the -7, right, to get this expression over here for y. Okay, now with this, right, I can also get the expression for dy dx. So dy dx, right, making use of this with the values of a and b over here. So 3 times 2, so this is 6x squared minus 7. So this is the dy dx. Okay, so we are not done yet. So far we've gotten this, we've gotten this, we've gotten this dy dx already. Okay, so let me clear up the space here first, right, so that we have a bit more space for the next part. Okay, so with this, right, so let's continue. I think let's continue with this first to find the value of y and to find the value of tangent, okay, when x equals to 1. So second stage, so when x is equals to 1, right, when x is equals to 1, so y is going to be equals to -5, okay, and then dy dx is going to be equals to -1. Okay, so with this, right, we've done our part to find y and the gradient of tangent. So now last but not least is the equation of tangent. So the equation of tangent at x equals to 1 is going to be y minus y1 equals to m x minus x1 over here. So altogether this is going to be y negative x minus 4. Okay, so this will be the final answer for this question 3. Okay, so hopefully with a little bit of planning, it will help you to roughly find out what we need to find. Okay, so especially when it comes to questions regarding coordinate geometry for this. Okay, so one of the heuristics that we can do is to work backwards from the final target that we have. Okay, so let's move on to the next question. So moving on to exercise 2, right? Now we are going to find the exact coordinates of the stationary points on the graph of y equals to x cubed minus 7x squared plus 7x minus 5. Okay, so the first thing that we need to do is find the exact coordinates of the stationary points. Okay, so this is one thing that we shouldn't miss, even though it's in the question stem. And then afterwards, determine the nature of the stationary points, and then we're going to sketch the graph. Okay, so we have a few instructions for us to do. Okay, so first, now how do we find stationary points again? Stationary points, right? The concept for stationary points is that it happens when dy dx is equals to 0. Okay, so over here I'm going to start off with y equals to x cubed minus 7x squared. Okay, maybe I'll just put this a little bit lower. So y equals to x cubed minus 7x squared plus 11x minus 5. So differentiate this. So bring down the power minus 1. Alright, so I'll get something like this expression over here. Okay, so at the stationary point, your dy dx will be equals to 0. So we will set this to equal 0, and this expression over here will be equals to 0. Okay, so how do we factorize this? We are going to factorize it like this. Minus. Okay, so x here is going to be equals to 11 over 3, or x is going to be equals to 1. Okay, so far this is the x value, but double check again, we are looking for exact coordinates, right? So means we are going to look for the y value over here. Okay, so here I pull up my calculator to show you how am I going to go about to do the calculation, right? Using my calculator, right? So what I have here is, so first what I need to do is I will need to sub in x equals to 11 over 3, right? So the way that I will do this is instead of typing in the whole bracket 11 over 3 cube and so on, right? I'm going to make use of the smart feature copy and paste. I'm going to make use of the history so that I can get the answer that I want, right? So first I'm going to store this value into the variable x. So I'm going to put 11 over 3, store this, right? You see this button store over here into the variable x, right? I press enter. So this is going to be give me 11 over 3 lah, basically. Next, I'm going to type in the expression. So this is x power 3, press to the right, minus 7x squared plus 11x. I'm typing it slow because yeah, if I type fast, the software wouldn't read. Okay, so I get like this, right? I press enter. This one give me in a decimal form. So let me change this answer to fraction. So I'm going to put second negative over here for the answer. Because I want to change to fraction, right? It's actually a math function. First one, change to fraction. Okay, so answer change to fraction. I'm going to get negative 256 over 27. So over here, my coordinate y equals to negative 256 over 27. Okay, so this is the first one. Now, next one, I'm going to store into x now, right? So replace x with 1. Then using the history function, I'm going to go back, press enter to call this down here. Then I'm going to enter again now with x equals to 1. So you see now the value changed already. So this one over here, y equals to 0. So this is how I make use of the calculator to do to calculate things fast. Okay, now so I've completed part 1. So right now we have two coordinates already. I think I will just list them out together with the nature lah, whether is it maximum or minimum. Okay, for us to determine, right, the nature of the stationary points, generally we have two methods, right? The first method is our first derivative test, where we need to write down the table and so on. The second method is our second derivative test. Now, there are benefits to each test, right? So the first derivative test, the usefulness, the pro, is that we can make use of the table to find the gradient of the curve at different points, right? And we can use that for functions that are not easily differentiated again, or if the function looks complicated. Okay, we can make use of the first derivative test, right? The con is that it's clunky because you need to draw two tables. Okay, now the second method, second derivative test, right, is useful if you can differentiate the function easily for the second time. Okay, so if you can do that, then it's very easy, and then you just need to sub in and test. Okay, now the con is that it will be not useful if you get 0. So when when the second derivative equals to 0, this is when it is inconclusive, and then we will need to go back to the first derivative test. Okay, so this one is something for us to take note. Right, so what are we going to do is let's find the second derivative first. So I'm going to look for d2y dx squared, right? Second derivative. So I'm going to differentiate this one more time, right? Differentiating this one more time, bring the power down, power minus 1, bring the power down, power minus 1, differentiate constant equals to 0. Okay, so what we're going to do is I'm going to sub in. So when x equals to 11 over 3, the second derivative. Now, we always need to evaluate, right? Remember, so the key thing is that we need to evaluate and find the value of this. So what we're going to do is when x equals to 11 over 3, right? 11 over 3, store into x first. Okay, you see, I'm missing one, yeah. Okay, second, insert 1, okay? So store. Next one, I'm going to key in 6x minus 14, right? Enter, this will give me 8. So this 8 is greater than 0. So it tells us that this point, 11 over 3 and negative 256 over 27, this is a minimum point. Okay, so this is for the first one. Now, then when x is equals to 1, right? So d2y dx squared. I think this one no need calculator, you can just put in. This is actually negative 8, which is less than 0. Okay, now, so this one over here, 1, 0 is a maximum point. Okay, so there we have it. We have the part 1, and now we are going to sketch the curve, right? So we're going to go to here, right? Let us plot this graph. So we're going to get x cubed, press right, minus 7x squared plus 11x minus 5, right? What we're going to do is we are going to do the zoom first, right? Zoom standard number 6. Okay, so let the thing draw the graph, and then you can see that actually it plots out to something like this. Okay, so just nice over here, right? Now take note now, let us check the function, let us check the points over here, right? So I'm going to do a zoom box to roughly check my points. Okay, so I'll go slightly above, maybe I'll go around 1 to check what's going on, and negative 1 to check what's going on. So I think with your calculator you can do this a bit faster. Okay, I'm going to press enter to lock in this point, and then I will open up, okay, slowly. Okay, so now you can see this box, right? I want to focus on this box so that I can see what's the behavior here. Does it pass through the axis? And I want to see the behavior here as well. Okay, so let me enter and let this plot out again. Okay, so obviously this point up here is the maximum point that we've already found, right? This point down here is the minimum point that we found. And what we need to do is I'm going to find the x-intercept. But x-intercept, right, technically we don't need to use the graph for this because we can just sub in 0 over here. Okay, we can just sub in 0, and then the y-intercept will be just negative 5, right? So let us do this as a reference. Okay, now let's go out to the zoom standard. Now let's take this as a reference and let us sketch the graph now. Okay, so after roughly sketching this, right, let's label this is actually 5. This one over here is 1, 0. So I'm just going to put a 1 over here because they never ask for coordinates. Now this one over here obviously has to have a coordinate. So I'm going to put in 11 over 3 and a negative 256 over 27. Okay, and here this is y equals to x cubed minus 7x squared plus 11x minus 5, right? Using this calculator thing as a reference. Okay, so once again, in this question, right, it's a very straightforward question. The procedure is standard, and I showed you how do we make use of the calculator to get the image that we want and to do calculations fast, right? Definitely you can make use of your old calculator if you feel that it is faster, but we still, as best as possible, we try to make use of the memory, right, of the old calculator to do calculations. Okay, so that's for question 1, right? Moving on. Okay, so part 2 over here, given that fx is this, show, right, keyword over here, show that fx is increasing for this range over here. So we have one detail over here, and we have that fx is increasing. Okay, so concept again, when fx is increasing, right, so the concept is that dy dx, the value of dy dx is positive because the gradient must be positive for the curve to increase, right? So I think this one we don't need our calculator. Okay, and now let us do dy dx, and let's find the different derivative first. So starting with fx equals to 3e power x minus x power negative 1, writing in a power mode. Now differentiate this, f prime x will be equals to 3ex, because when you differentiate ex, it remains the same. There is no chain rule over here. We can just take this directly. This one, bring the power down, power minus 1. Okay, so writing this, right, this is 3e power x plus 1 over x squared. Okay, so this is the expression that we've got. Now, so show that this is increasing means that I'm going to show that this is positive. This is more than 0. How am I going to do so? I'm going to make use of this this detail over here. So for values of x more than 0, now then we analyze this one term by term. Okay, so let's take a look at this one first. Now e power x is always a positive number, correct? So for x to be positive, e power x is always positive. 3e power x is also positive. And at the same time, x squared is positive, right? And 1 over a positive number is also a positive number. So adding on together, 3e power x plus 1 over x squared is more than 0. So f prime x is more than 0. So the conclusion is fx is increasing. Now, so you're going to ask me, right, hey, this one is very redundant, right? Why do we need to present like this? So for in mathematics, right, so this is the way that we prove, right? So when we want to prove that something is always positive or always negative, we're going to look at term by term, and then we're going to sum them up together, right? If both the sum are positive, if both are positive number, when they add them up together, it's also positive. So this one is really tapping into the logical proof or the logical thing on why is this whole thing positive, because the individual parts are positive. Okay, so even though the steps seems redundant, right, but I hope that you appreciate this rigor and this level of detail that we will need to present. Okay, so so this one is how we show that some inequality is always positive. Okay, so this is for question 2. Now let's move on to question 3. Now question 3, instruction, find the exact coordinates of the stationary point. This is the graph given, right? And what else do we need to find? We need to determine the type, determine the nature. Is it maximum, minimum, and so on? Okay, so what we're going to do is we will write down our function. So we're going to start off with y equals to x power 4 minus 1 over 4 ln x. Okay, so we're going to start with this. Then, because we want to find stationary point, right? So we need to find the derivative. So dy dx was equals to, bring the power down, power minus 1, minus 1 over 4. Differentiating ln x is just 1 over x. So combining them together, so this is 4x cubed minus 1 over 4x, like that. Okay, so 4 and x you can multiply together at the denominator. Okay, so in order to determine the type, right, now does this function looks easy to, oh sorry, before that we have to find the exact coordinates. So at stationary point, right, so this one concept at stationary point, so the derivative equals to 0. So this means 4x cubed minus 1 over 4x is equals to 0. Right? So there are many ways to do this. I will choose to move this to one side. Okay, I will move this to one side over here. Right? The next thing I'm going to do is I'm going to multiply this 4x over here. So in total, I'll have 16x power 4 equals to 1 over 1. So this is going to be equals to 1 now. Okay? Now then x power 4 will be 1 over 16. Okay, so continuing in this side, okay, so x, right, will be equals to plus 2 or negative 2. Why plus or minus? Because this is an even power. So when you take the root, right, we are also taking the fourth root, right? So it's like you think of taking square root and square root lah. Okay, so when we want to unsquare or want to undo an even power, we need to consider that actually negative numbers, when you raise to an even power, it will still be a positive number. Okay, so this is something for us to take note. Okay, so there's a positive 2, negative 2. Sorry, shouldn't be positive 2, negative 2. It should be 1 over 16, right? So positive half or negative half. Okay, now over here, then let's check, do we need to reject anything or not? In fact, actually we do. Over here, right, we need to reject this negative half. Why? Why do we need to reject? Reject because x is greater than 0. Now, then some of you may ask, right, why is x greater than 0? For this, we will need to look at this function itself, right? So x power 4, right, is defined for all values, real values of x. Okay. Now, however, for ln x, right, there is no such thing as ln of a negative number or even ln 0. So what do we need to do is the x, right, over here, because of this ln x, it will restrict x to be greater than 0 only. So the values of x that we will consider are just positive values of x, which is good because it helps us to restrict to this. Okay, so when x equals to this, right, I think because we are looking for the coordinates, so let's find the coordinates of y. So y is going to be equals to half power 4 minus 1 over 4 ln 1 over 4, 1 over 2. Okay, so something like this. Now let's put this over here. So this one, let's simplify this. 1 over 16 minus 1 over 4 ln, so this is 2 to the power of negative 1. So because of this, I can use the law of logarithm to bring the power in front. So over here, when I bring the power in front, negative 1 times negative 1 over 4, so this is going to be plus, okay, plus 1 over 4 ln 2. Okay, so this is the y value. Okay, now then we need to test and see whether is it a maximum, minimum, right? We need to test for the type, right? So we will need a second derivative. Or actually, if you want, you can test using your first derivative test, but you observe over here, this one over here, right? It is very easily differentiable. You can differentiate very easily. Okay, so I'm going to write this as equal to 4x cubed minus, okay, common mistake, now 1 over 4 is the constant. So this is just 1 over 4. X is the one that I will change to power negative 1. This power negative 1 only belong to x. So if you were to write 4x negative 1, it's wrong because it's like that. The negative 1 only belong to x. If you want to the whole thing, you have to put bracket for the whole thing. Okay? But the thing is, if you bracket the whole thing, you cannot differentiate because the 4 is still inside. So what we'll do is we only concern with 1 over 4. So we keep 1 over 4 alone. And then x, right, we raise power negative 1. Okay? So over here, let's differentiate. So bring the power down. Power minus 1. Bring the power down. Power minus 1. Okay? So with this, I have half x squared. 12x squared. Plus 1 over 4, then the x can go into the denominator. So 1 over 4 x squared like this. Okay, so with this, right, I will put in the value half. So when x is equals to half, okay, so putting all this in your calculator, d2y dx squared is equals to 4. Okay, so putting this in the calculator, we get this. So because of this, this is more than 0, right? So dot, dot, dot. So the coordinates half and 1 over 16 plus 4 ln 2. So this is exact coordinates, right? Exact means exact value. Numerical value means 3SF. Okay, so this exact coordinates is a minimum point. Okay, so there we have it for this question 3. Okay, so moving on to exercise 3. Now for question A, right? Question A is a bit separate from question B. So even though it looks like they are together, right? But question A is alone. Then the diagram will go with question B. Okay, so for exercise 3, it's mainly just this sentence. Okay, so over here, what we're going to do is we want to find the x coordinate of the point on this line, and they say that xy is a maximum. Okay, so what we need to do, right, is I'm going to come up with another term, right? So I will let s be equals to xy first. Okay, now then, because right now we have two variable, right, I think we should write this as one variable, and the y is actually on this line, correct? So technically I will just replace y with just this expression over here. So s equals to x times 5 minus 2x, right? So this one looks very abstract. Okay, it looks very abstract on why we are doing this, but so that this one over here, right, is going to be a misconception. But when we are looking at this, right, we need to think that xy, right, is a new quantity. Okay, so xy is a new quantity that we need to define. So I'm going to let this character s be xy first, then replace the y to get this, so that it's just in one variable. And because of that, right, I can expand this very nicely and use this to find the derivative so that it is maximum, right? So the derivative over here, 5 minus 4x, like this, right? So when, okay, so xy is s, so when s is maximum, the ds, d theta that we had just now equals to 0. So 5 minus 4x equals to 0. X is going to be equals to 5 over 4. So done already. So this is the x coordinate. Okay. Now, so ideally speaking, right, what you also need to judge by the amount of marks. Okay. So ideally speaking, we should be testing whether is it a maximum or not, right? So to test whether is it maximum or not, we'll need to do the first or second derivative test for this, right? So to test the nature, so up to you. If you prefer the first derivative test with the table, up to you. For me, right, this expression can be differentiated very easily. So over here, I will look at d2s dx squared. If I differentiate one more time, right, it's just negative 4. And this one is going to be less than 0. So because of this, right, so x equals to 5 over 4 will make xy maximum. Okay, so by right, we need to test, right? But you also judge by the amount of marks. So let's say if you have 1 or 2 more marks, then like you counted for here, then yeah, it is a good sign for you to try to test this. Okay, so something like this. So this is for part A. Now let's look at question B over here, right? And let's read this slowly, and let's analyze this slowly first, okay? So first and foremost, let's take a look. Now we have this big diagram over here that we haven't made sense yet, and this diagram where all the dimensions are in meters shows a rectangular wall with 8 rectangular windows. So I'm going to highlight. We have 8 rectangular windows, each of them x by y meters, set 2 meters from the boundary of the wall. So over here, right, what is going on is I have 1, 2, 3, 4, 5, 6, 7, 8, 8 windows over here. All right. So this is the first thing that I need to take note. Now, given that the total area of the 8 windows is 240 meters square. So what I need to do, I need to show that the area of the brickwork, okay, shaded in the diagram is going to be this expression over here. Okay, so the shaded part is actually here, right? So I want to show that this shaded part is equals to this equation over here. Okay, so let us take a look at what are the strategies we can do to model this problem. Now, of course, it looks very complicated at first, right? So let us dissect one by one. Okay, so the first thing that I will take note is now this, let's make use of the total area of the 8 windows is 240 meters square. What are the dimensions of the window? X and y, correct? So the area of one window is just x times y. Agree? Right? So with this, right, So let's take a look with this over here. So the area of the window, so 8 windows would be 240 meters square. So this means that 8 windows, so 8 times x times y is equals to 240 meters square. So I will leave this information here like this first. Now, then the next thing that I will take note, right, is I want to find the area of the brick, right? So technically the area of the brickwork, right, I can actually take the whole thing minus off these 8 things, right, correct? Or actually I can minus off 240 meters square, right? I can do this. Okay, so what I will do is, now what is the area of the whole thing? I'm gonna of course need this dimension, and I'm gonna of course need this whole dimension over here. So let's take a look at what is the total dimension. Now over here we have 2 x 2 x 2 x 2 x, correct? In total, this is actually how many 2's? We have 10 plus 4x down there. So over here, this is 10 plus 4x in total. Okay, now let's take a look at this side over here. Now we have 2y, 2y, and 2, right? So technically in total, this would be 6 plus 2y. Okay, so the area of this whole thing will be just the product of these two quantities. Okay, so let us put this down into the equation below. So the area of the whole thing, right, is actually now 10 plus 4x multiplied by 6 plus 2y minus 240. Okay, minus the 8 windows 240. Okay, so let's take a look and see, right, what is the working now. So over here we have x, we have y, correct? But the thing is, right, we also have, we want to make this to one variable, because if you notice over here, it's only x. So we need to replace y away. And where do we replace the y? From here. So over here, right, what I'll do is I'll divide by 8 first. So this is going to give me 30. Then y is going to be 30 over x. So this is the expression for y that I will use it for later. So over here, right, I'm just going to replace y with this first. Okay, so 6 plus 2y. So 2 times this is going to be 60 over y. 60 over x. Okay, at the back minus 240. So let me expand now. So this will be 60 plus 600 over x plus 240x, and that, right? Plus 24x plus 240 for this one. At the back over there, minus 240. So what is going on would be, we have this 240 and this 240 will cancel off. At the end of the day, this will be just 60 plus 600 over x plus 24x. And then we have completely shown that this is the expression for A. Okay. Now the thing is, right, if you cannot get this, right, over here, technically speaking, you can actually move on to parts 2 and parts 3. Okay, so if you really cannot, just move on, making use of this expression over here. Usually part 1 show, right, is because a lot of students tend to not be able to make it. So they will break this down further, so that they will allow you to break this question down further. So this is like a checkpoint to make sure that everyone got this, so that you can proceed to do parts 2 and part 3. Okay, so this is going to be part 1. So moving on to parts 2 and parts 3. Now given that x and y also vary, right? So find the value of x and y. Okay, so we want to find the value of x and y. So this one, be careful. This one over here, read carefully, right? They want us to find the value of x. They want us to find the value of y. Okay, sorry, it's wonky, right? For which a is a minimum. Okay, so let us take a look. So over here, right, I'm going to write this in a friendly form first. Okay, so 600 over times x power negative 1 plus 24x. So because I want to look for minimum point, right, I need to get dA, ds, dx. Okay, so differentiate constant will be 0, differentiating this, minus 600 x power negative 2 plus 24. So this one over here writing nicely into a nice fraction. So this is going to be 600 over x squared negative plus 24. Okay, so when this is a minimum, so at the minimum, right? Sorry. Okay, so dx would be equals to 0. Okay, so this whole expression over here is equals to 0. So rearranging, right? So I will get something like this, 24. So 600 equals to 24 x squared, right? So dividing it out, right? So x squared would have been 25 and x would be plus 5 or negative 5. However, x, right, is the length of the window. Okay, apologies about that. So we will reject the negative value of x because x is a positive number. Okay, it is the length of a window. Okay, so x will be equals to 5. And now let us make use of the y. And just now our y, right, it will be equals to 30 over x. So this is going to be 6. Okay, now, and at the same time also, a is the minimum, right? So let's test. Now, over here, let's observe this one over here. Is it easy to differentiate this? Actually, it is. So let us test, even though they never say, right? So let us test. Okay? So if they really don't want us to test, I believe they would either reduce the marks or they will just ask us to not test. There's no need to test. So let us differentiate this. Now over here, bring power down, power minus 1. So this would be 1200 x power negative 3. Differentiating the constant will give me 0. So writing this out over here, 1200 x cubed. Okay, so when x is equals to 5, the value of the second derivative, subbing in this one over here, right, it will give me a value of 48 over 5. And this is a positive number. So the conclusion is when a is minimum, x equals to 5, y equals to 6. Because this tells us that a is minimum. Okay, maybe, yeah. Or maybe a is minimum when, yeah, x equals to 5 and y equals to 6. Okay, so maybe this is a better way of phrasing. Okay, like that. Okay, so this is part 2. Okay. Okay, so having this for part 3, so a is a minimum when x equals to 5 and y equals 6. So now what we're going to do is we want to find the minimum value of a. So what are we going to do when we find the minimum value of a? We're going to make use of the x because a, right, is defined in terms of x only, correct? Actually, more like we can define using x lah. Okay, and it's already given in the part above over here, right? Already give x. So what we're going to do is we're going to make use of the x that we found to give a the minimum. Let's put in over here, right? So a minimum would be equals to 60 plus 600 over, now sub in 5, plus 24, sub in 5. Okay? So this is going to give us 300 meter square. Okay, so this one over here would be part 3. Now let us move on to exercise 4 over here, right? And let us try to analyze the question and see what's the best course of action. Okay, so over here, we read this as, now the population of Americans, right, as a total percentage of the population is FT, right? So I want to highlight something over here. Now this one over here, right, is as a percentage of the population. So it's not just population itself, it is a percentage. Okay, so the question over here is saying that this function gives us percentage and t is between 0 to 20. Okay, sure. And then T over here is measured in years. Okay, and T equals to 0 equals to 2000, it corresponds to the year 2000. Okay, now over here, right, let us take a look at the instruction, and they are asking at what rate, okay, was the percentage of Americans aged 55 and over changing at the beginning of 2000. Okay, so let us analyze one by one. First one, at what rate? They are asking us to find the rate of change, correct? So if it's simply just rate of change, then this was just like a dy dt or a dx dt. Okay, so this tells us, right, because this is defined in terms of f, so I'm going to look for f prime t like this. Okay, so that's the first one. Second one, at the beginning of 2000, right, this is t equals to 0. So actually this one over here, t equals to 0. Okay, now, so what are we going to do over here is, right, are we going to differentiate this or not? Is this very easy to differentiate? Technically, yes, it is easy to differentiate, right? But then, right, because they only want this answer over here and sub the t, correct? So actually what we need to do is we just need to make use of our calculator, right, to evaluate this. There's no need to do the explicit differentiation, right? And then they are not asking us to find exact value. Okay, so take note now, they are not asking us to find the exact value, and this is the opportunity for us to make use of the calculator to find the numerical value. Okay, so let us set up our calculator. Okay, now so let's bring out our calculator over here, right? Now, how do we key in the derivative of a function? Do we need to like differentiate first to submit? Actually, no, our calculator, our GC can do it for us, right? So let us key in, right? Let us key in this expression here with the derivative into a calculator. So how do we find the derivative? Once again, it is going to be at the math. So it will be under math, number 8, and deriv, right? Do you see number 8 and deriv? So you get d something, right? So d dx of 10.72. So we key in the whole expression, 0.9t plus 10 close bracket to the power of 0.3. And then we want to evaluate when x equals to 0. You see this? Right, so let us put enter. Okay, so over here, right, what are we going to write over here is we're going to write f prime 0 is going to be, because f prime is the derivative, right, once more, so this is a d dx, okay, right? So this one over here is dy dx, right? This one over here is when x equals to 0. So sub x equals to 0. Okay, so this one over here from the calculator will give us 0.578 to 3 significant figure directly. Okay, so there's so because they didn't ask us to find exact value, so and this is a contextual question, so I think it is okay for us to make use of the ddx function like this. Okay, now same question, at what rate will the percentage blah, 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 will be changing in 2010? Right, so 2010 over here, right, means that we are going to look at when t is equals to 10, correct? 10 years from 2000, the year 2000. So what I'm going to do is, am I going to like type the whole thing again? No, waste time. Press up, and get this, press enter to call this function down. I'm going to put in 10 over here directly. Don't waste time. This is a very time-saving thing. So put this in. So I'm going to write this as b f prime 10 dy dx when x equals to 10 is 0.368 to 3 significant figure, just like that, just by using your calculator. Okay, now next one, what will be, right, they are asking now is the percent of the population of Americans, okay, the year in 2010. Okay, so same thing, the t equals to 10, but we are looking for the percent of the population. So if you read carefully, right, this is the percent of the population. So we are looking for F10. Okay, so what we do is we need to substitute the whole thing with 10. So what I'm going to do is, am I going to type the whole thing again? No, waste time. I'm going to go up and up, right? Let me try. Okay, so what I just did is I went up, okay, I copy this function down and I delete the ddx in front. Okay, I scroll all the way to the front and delete. So I'm going to enter first, right? Now over here, let me store this first. Now I'm going to store 10, store into x again, right? Then I will go up to this, right? Go up to this, pull this down and enter. So I'm going to get 25.9310. Oh, actually, right, if you notice over here, x is already 10 lah, right? Or up here, right? So technically speaking, you can get the same value also. Okay, so over here, so what we're going to do is, I'm going to write C. I'm going to write F10. F10 would be equals to 25.9 to 3 significant figures. Okay, so this one is just mainly calculator work. Okay, for if they never ask for exact values, and if they never ask us to solve for maximum minimum, and if they just ask us purely what's the dy dx, value of dy dx for a certain value. Okay, so this is for exercise 4 question 1. Now let's continue on to the question 2 of exercise 4. So over here, let's read this together. We have the demand equation, right? Is given by x or f of p, right? And then x is measured in units of 1,000. Very important, So this one over here, units of 1,000. Okay. Right? Then this one is the quantity demanded each week. P is the price in dollars. Okay. So what we're going to do is we will find the rate of change of the quantity demanded of the wristwatches with respect to the unit price. So if they just purely say, right, if they just purely say the rate of change of quantity demanded is dp dt or dx dt, that's all, with respect to time. Okay, but they say that is change of quantity with respect to unit price, we are looking for dx dp, or in this case we are looking for f prime p. So that means we need to differentiate this. Now looking at this function over here, is it going to be easy to differentiate? Actually yes lah, because we can just separate this and then we can just write this is power half and then this is a power function, right? But then are we going to do that or not? It's really waste of time, because they are asking us what is just dx dp, or what is the evaluated value. So what we're going to do is same, we're going to make use of our calculator for this. Okay, so when the unit price is 25, so means that when the thing that I'm going to differentiate is 25. Okay, so let's turn on. Okay, so it's going to be a bit confusing, right? Because right in our calculator, right, is defined as d dx, but over here the x is going to be on top. Okay, but you don't care because calculator not as smart lah. You just need to substitute, as in replace p with x with p in your brain. Okay, so the ddp, right, is actually like d dx like that. Okay, so you just know when you type in dx, right, this x actually means price lah in your brain. Okay, because what is going on here and what's going on in the calculator is a bit different. Okay, so I want you to realize that. Okay, so don't ask me why x is this, because x, right, even though x is here in the question, but in the calculator x is just x. I cannot type in p. There's only x over here in the button. Okay, so be careful. So when the unit price is 25, right, I'm going to store 25. Oh, actually don't need to store, just key in directly. Okay, so call the math differentiate x, right? And over here, I need to key in the expression. So this is 10 times of second square root. And then I'm going to look fraction, right? Okay, so where is fraction? This is alpha f1 over here, right? This fraction over here, I put in 1. Okay, so 50 minus the variable that I'm going to differentiate divided by the variable that I'm going to... So yeah, you see the confusion now. Okay, so then I sub in when the unit price... Okay, so over here, when the unit price is 25. Okay, so this one, I put in 25 over here. Right, so let me evaluate this and I get, okay, negative 0.04. Okay, so f prime 25 is equals to negative 0.400, okay, 00 and so on. Okay, right? So this one is f prime 25, or more like I just put 0.4 because I think at the back is just 2 lah, so I think it doesn't really matter. 400, okay, never mind. Okay, but now, right, x is measured in units of 1,000, correct? Right? So this tells me that, right, what is the rate of change? So the rate of change, right, is, okay, let's write this in the context. So this is negative 400 wristwatches, right? So the dx over here, this is the quantity of wristwatches, and then this is the price, right? So this is per unit price, for dollar per, what's the question, for dollar price, okay, for per dollar price increase. Okay, so like that. Okay, so making use of the calculator to get this, all right, and because, right, this one over here is dx dp, x over here is the number of wristwatches, this one over here is the price, right? So this one is negative 400 wristwatches per dollar price increase. Okay, so this is what we mean for dxdp over here. Okay, then we want to translate this into word and we put it in the context over here. Okay, so this is how we handle exercise 4 question 2. So that's it. Congratulations. That's the end of all our exercises in chapter 6, application of differentiation. So hopefully, in case you don't understand, right, you can always revisit this video, or you can look for me or your tutor. All right, I'll be very glad to help you with all this. Okay, so that's all that I have for chapter 6. All the best. All right, and wishing you a very productive time learning the calculus portion for H1 math. Okay, that's all. Bye bye.